Okay, so this is assignment number 18. It was to do with integration. Let's get straight into it. Let's first just discuss what this actually means here. Now, this is the graph of y equals x squared, and now the integral between a and b, you put down your a and b wherever they are, you draw vertical lines from them, so the lines x equals a and x equals b, and the integral of x squared dx between those 2 points is the area underneath the graph above the x-axis and in between those 2 lines. So the integral of that is that green area. Now the same thing for here. Now x is just a line, y equals x. But I still put my a and b's down, and I still say the integral of this is the area underneath that graph above the line and between the 2 points. And so what this question is talking about is it's saying there are some values, a and b, for which this green area equals that red area squared. And that's all this question is asking about. Okay, well it starts off by saying in the case a is 0. So we can just put a as 0 into our formula. Find the value of b. Well, I know how to integrate. I'm sure you do too. Just before we do though, what this is saying, if a is 0, then that a point that I had there before has been pulled right back to the point x is 0. And so we're just evaluating all the way up to the y-axis and up to our line here. That's what we're doing. But anyway, we can do this. That's x cubed over 3. That's x squared over 2. You put in your 2 limits. You start with the one at the top and you do this one, and then you take away when you substitute that one in. I'm sure you know how to integrate if you're watching this video. This is obviously 0. This is obviously 0. So we just end up with this because b squared over 2 all squared is b to the 4 over 2 squared, which is 4. Cross multiply. In fact, no, that's not what I'm going to do. I'm going to say, well, b isn't 0, so I can divide by b cubed, both sides. And now I'm going to times both sides by 4 to get rid of this, and I end up with b is 4 over 3. So my answer is saying when b is 4 over 3 and a is 0, this area is equal to this area squared, which it doesn't really look like it in my picture, but that's all we did there. Okay, in the case a is 1, show that b satisfies this. Okay, so I'm going to put a as 1 into my thing. So there's a as 1. Let's do exactly what we just did. This is going to look exactly the same, except there's 1s here rather than 0s. 1 cubed is obviously 1, and this is a common denominator, so I can put those fractions together for a b cubed minus 1 over 3 and a b squared minus 1 over 2. Now, it's tempting to just square this out, but I'm going to be a little bit more tricky than that. I'm going to say b squared minus 1, that's actually a difference of 2 squares. That's b plus 1, b minus 1. And here I'm going to be even more tricky, and I'm going to say, well, that can factorize into b minus 1, b squared plus b plus 1. And check this expansion formula, please. Just pause the video and check that. But I think this is one of the things that I just recognize like this, but I just kind of recognize this and think, well, that can often be written as that. Maybe that would be helpful. But yeah, check it there. But this is going to be super helpful in this time, because when I square this, now when you square a fraction, you just square the top and the bottom separately. So the bottom is going to be 4, 2 squared. And when you square things that are multiplying, you just square them separately as well. So that's going to be b minus 1 all squared, b plus 1 all squared, just like so. And why is this good? Well, because this b minus 1 cancels with one of those b minus 1s, which is good. And now I'm just going to, which leaves me with this when I cancel those out. And now I'm going to cross multiply. So the 4 goes over here. So all those have 4s in them now. The 3 goes over here. I've expanded that out. And now I'm going to expand all of this out. Pause the video and check my maths, but I think this is b cubed with a 3 there, plus 2b squared, but there's another 3 there, plus b, but with this 3, and so on. And when you move the minus 4b over, the 4b over, the 4 over, I think you end up with this, which is exactly what they wanted me to have. So yeah, I think I'm done there. Show further with the help of a sketch that there was only one real value which satisfies this equation here. So let's try sketching this then. So get some axes down. These axes are going to be from y to b, which is a bit weird. Usually you have an x-axis, but this is a b-axis, I guess, which is cool. The y-intercept is clearly minus 7, which is good. And now the other thing I can easily get is, well, this is a positive cubic. When b is massive, the cubic is all the way up here somewhere. When b is massive and negative, the cubic is down here somewhere. So I know it goes roughly in this area and it goes through this point here. Now to get the rest of the sketch done, we've done graph sketching in step before. You find some turning points, so you differentiate, and the turning points are when this is 0, or the stationary points maybe I should say more correctly. So this here is 0. This doesn't look like it factorizes, but thank God it does. And you get the answers of b is 1 or b is minus 7 over 9. So this graph or curve is stationary at b is 1 and b is minus 7 over 9. Now I need some more information. I need to know exactly where the graph is at those 2 points. So I'm going to put my b value into here and find what my y coordinate is at the value b is 1. So when I put b as 1 in here, I get, well, 3 minus 1 minus 7, which is minus 5, minus 12, minus 7 is minus 12. Check that for yourself, but I end up with the point at 1 minus 12. So down here, below this y-axis, the y-intercept, down here. Now, we come to this one. Now, you don't get a calculator in STEP, and I absolutely am not feeling hot about putting this into here without a calculator. So I'm going to be much more intelligent than that. This is a negative number. And listen carefully, because I'm going to try and say this as precisely as I can. This is a negative number. When you cube a negative, you get a negative. And times it by 3, it's still negative. So this is negative. When you try and put this into here, this is negative. Whatever it is, it's negative. When you square a negative, you get a positive. And so when you take that away, that's going to be taking away a positive, which is going to make it smaller. So all of this, if this is negative and then you take away a positive number, you're still negative, right? So all of this is negative. I know that for sure. Without putting that in, I know all of this is negative. Now for the tricky bit, I take away 7b. Now 7 times a negative is a negative, but then I'm taking it away. So I'm actually adding in a number here. So whilst all this is negative, and that's great, I'm adding a number here. So I don't know what all of this is. It could be positive. But now we think, well, this number is less than 1. So when I times it by 7, I can almost think of that as kind of scaling the 7 down a bit. Like this thing here is going to be less than 7 because it's being multiplied by something less than 1. So I'm adding in, remember, because the 2 negatives make me adding in a number, I'm adding in a number less than 7. But then I'm taking away 7. So in total, these 2 terms, because this one is bigger, these 2 terms are going to be making my whole thing smaller. So I have a negative here between those 2 terms, and then these 2 eventually will make it even smaller, which means eventually y I can definitely say is a negative. And that's all I really need to know, because I know that the b coordinate is minus 7 over 9, and y is just some negative number. And when I put and it's stationary there as well, and it's stationary here. So when I put the curve through that, you can see why I was trying so hard to argue that, because what I'm trying to show is that there's only one root. There's only one time that this graph is 0. And the fact that this is below the x-axis, or the b-axis, I guess, because this is negative, means there's only one root and it's over there. So my sketch is now showing that. And I'd have to write down that carefully if I was in a real exam to justify this. Okay, show that this root is between 2 and 3. Well, I can clearly see it's bigger than 1, but show it's between 2 and 3. Well, I can do that nice and easily, right? All I have to do is take the equation, work out what it is at 2. So what is it at 2? Well, I just put 2 into there. You know, pause the video if you want to do the maths, but you get y is minus 1. So at 2, y is minus 1. And then I just say, well, what's it at 3? Again, do the maths. You can pause the video if you want to do it, but y is 44. And so therefore the root is between the value of 2 and 3, somewhere in between those. Excellent. Part 3, show this thing. Now, what I can immediately notice, this looks a bit confusing, but what I can notice is that in part 1 and part 2, they gave me a value of a to use. In part 1, it was 0. In part 2, it was 1. They haven't done that here. So what I'm going to assume I have to do is take this equation here and just do it with an a. Right? So let's just do that. And it doesn't look any more complicated, really, than it did when it was a 1 or a 0, right? You just end up putting an a in here. And this is a common denominator, and so is this, so we can do this. And now, notice again, this is a difference of 2 squares. I've done this before, essentially when I had the b squared minus 1. But this is a difference of 2 squares, so I'm going to factorize it. And this as well, I kind of did this when it was a b cubed minus 1 as well. But this, we saw in a previous step assignment, that actually factorizes a difference of 2 cubes into this. That was a few step assignments ago. So I'm going to replace that with that there. And now, just like a few minutes ago, I'm going to cancel that thing with that thing. And that leaves me with this. I'm going to cross multiply. And I think that's all I've done there. So I've cancelled those two and cross multiplied. I've highlighted these two because notice now, P is B plus A, so this is P. And Q is B minus A, so that's Q. So the power of factorization, guys, I've immediately got to my answer. Well, I mean, I haven't, but this side is the answer. This is 3 P squared, Q, which is exactly what I needed that side to be, which is cool. I can expand this out. Now, I was a bit confused as to what to do here. The mark scheme did not do it how I'm about to do it. The mark scheme said, what you want to do is you want to take your two equations for P and Q, and you can arrange them for A and B instead. So like, for example, if you add these together, you get 2B plus nothing is P plus Q, divide by 2 and you get B. And you can do the same thing to find A. If you took these equations away, you'd find A. And then you would substitute your A and B into here in terms of Q, and then lots of things would cancel eventually and you'd end up with this. Now, I didn't think of that. So what I'm going to do instead is I'm going to flex incredibly hard on this step question. Because what I'm going to do is I'm going to take this thing here and I'm going to write it like this. So I hope you can agree that I'm allowed to do this. 3b squared plus b squared is just 4b squared. 3a squared plus a squared is 4a squared, and 6ab minus 2ab is 4ab. So this is fine. Now, why have I done it? The colors might help you to see, because this red thing here, that factorizes beautifully into this, right? Because when I expand that out, it's b squared minus 2 cross terms of ab plus a squared. Now, this has a 3 that I can factorize out to leave it behind this, but this also factorizes beautifully into b plus a squared. But remember, b minus a is q from up here, and b plus a is p from there. So I get 3p squared plus q squared equals 3p squared q, which is exactly what was required. So yeah, I mean, I only got this because I watch too much Black Pen, Red Pen. I'll put his link in the video in the description below. Okay. Express p squared in terms of q. Well, this feels rather GCSE-like. Let's just move that thing over, factorize out the p squared, divide by 3 over 3q and minus 1 or whatever. That's fine. We can do that. Deduce that this is true. Now, notice how b minus a is q. So actually, I'm being asked to show this, really. And now, let's just write down all the things we know clearly and carefully. We know that a is bigger or equal to 0, just because it's at the top there. We know that b is bigger than that and bigger than 0, again from here. So what else can we tell from that? Well, we can tell that p is bigger than 0 because p is made up of 2 positive numbers adding together. Right, so p is bigger than 0. I also know that q is bigger than 0 because if b is bigger than a, this is a bigger number, take away a smaller one, so q is bigger than 0. I also know that q is less than or maybe equal to p, because again, both a and b are positive, which means if you're taking away a positive number, you're going to be smaller than if you're adding it in, unless that number is 0, which it technically could be, in which case p and q would be equal. But otherwise, I can write that. Now, let's look over here. Q squared is positive because anything squared is positive. P squared is positive for the same reason. So here's a positive, here's a positive. That means for this to make sense, q minus 1 must be positive. Because if it was negative, this whole fraction would be negative, and then it couldn't equal this, because that's positive. So q minus 1 is positive. So q minus 1 is bigger than 0, which means q is bigger than 1. So I can actually refine this statement to say q isn't just bigger than 0 anymore, q is bigger than 1. Okay, and I've done half the work now, right? Because I've done this half of it. So I've done that bit. Now I just need to show this bit. And again, I'm going to be very careful here as I do this. I can square both sides of this. Now, you have to be careful when you're squaring sides of an inequality, because it's possible that you might have to flip this sign accidentally. Because if one of your things is negative and you square, you're essentially timesing by a negative, which flips the sign. However, I know from what I've previously written down that p and q are positive. So I'm allowed to square without worrying about that. So I am allowed to say this. Okay? So that's important. Here are all the things that I've just talked about. And now I'm going to finish up this question. p squared is bigger than q squared, and it's currently equal to all of this. However, if I replace that p squared with a q squared, I've made this side of the equation smaller, right? Because p squared is bigger. I've made this side of the equation smaller, which means this side now must be the bigger side. They were equal. I made this side smaller, so this side must be the bigger side now. Okay? Now, q isn't 0 because q is bigger than 1, which means I can just divide by q squared because it's not 0 and because it's positive. Otherwise, the sign might flip. And now I get to this, and this looks great. Just one more thing to be careful of, which is I want to times by this denominator to get it over here. But I'm only allowed to do that if I know that that's positive, because otherwise the sign might flip. But I do know that's positive because I've got it right here, but also q is bigger than 1, so that must be positive. I argued that on the previous slide, exactly why that is. But that's positive, so I'm allowed to times by it without fear of any problems here. And now, I mean, I'm good now, right? I expand that bracket out, add 3 to both sides, divide by 3, and I end up with q less than or equal to 4/3. So I had this half earlier, and now I have this half, and I'm done. Okay, so this is just a quick extra note about step support assignment number 18. So if you remember, I was doing part B, and I got kind of, it was A was 1, so I put 1 into the integral, and then I did some integration with the 1, and I got to this point. And if you remember when I was at this point, what I did was I said, well, this is a difference of 2 squares, so I factorized it. And I also managed to notice that this could be factorized into this. And eventually that meant some cancelling could be done, and that was great. Now, what if you don't spot that kind of thing? What can you do if you don't spot it? Well, you can get away with it. So b squared minus 1 over 2 all squared is just this bracket times itself. That's what squaring is. So that's going to be that there. So let's expand that out. So obviously this is going to be a 2 on the bottom, but this is b to the 4 minus b squared minus another b squared plus 1. So that's going to make that. And now I can cross multiply, right? And I can rearrange to end up with a quartic. And now I always get nervous when I see quartics because it's difficult to solve them, right? And I'm meant to show this, but I can't just divide by a b or anything like that. So how am I going to solve this? Well, to do this, what you needed to think was look back at the question. What is this question talking about? Well, it's talking about 2 integrals starting at 1 and ending at b. One of them is x squared and the other one is x. So can I think of any values of b for which I know that this area, this green area, would be equal to the red area squared? Can I think of any values of b for which I know that would definitely be the case? And after thinking about it for a second, I think, well, if I were to just slide this b over to this one here, and this one to this one here, then there'd be no area. And 0 equals 0, right? So if you slide b all the way over to 1, you just get this trivial solution that the 2 areas are the same because they're both 0. So b equals 1 must be a solution to that. And if 1 is a solution or a root, then b minus 1 is a factor. And now you could have got that by doing some trial and error, but it's nice to think about it like that because that does get you the answer in a nice, satisfying way. Now, of course, once you have b minus 1 as a factor, you take this thing here and you try and you break it apart into a b minus 1, and then you think, well, what's next? And now, again, you could do polynomial division here. If you watch any of my videos, you know that I just have a pathological hate for polynomial division. I don't know why. But instead, I'm going to compare coefficients. I know this coefficient because b, I need to get a 3b to the 4. So I need a 3b to the 3 here. I also need to get a plus 7. So I need a minus 7 over here. There's a minus 1 there. So I don't know what p and q are yet, but I think I can figure them out because looking at the b's over here, notice I've put a plus 0b in here, which is usually pointless, but it does at least help me to see that there are 0 b's over here. There must be 0 b's over here. Well, if I were to expand this for the b's, I'd get 1b from these 2 times multiplying. That would be a minus q lots of b. And I'd also get b's from these multiplying. That would be a minus 7 lots of b. So minus q minus 7 must be 0. So q is 7. Minus 7. So we can put that in there. So that's good. Now all I need is p. And again, I can just look at maybe b cubed coefficients for that. minus 4 over here. How am I getting b cubes over here? Well, we're getting minus 3 of them there, and I'm also getting plus p of them here. So minus 3 plus p is minus 4, p is minus 1, and I end up breaking it here. And now this means that either b minus 1 is 0, which is okay, or the thing that they're trying to, that they asked me to do, or that's 0. So it is possible, even if you don't notice the factorizations, but you just need to be prepared to think it through a little bit more. Always have in the back of your mind exactly what the problem is you're doing, if you can. And yeah, always remember the fact theorem and how to do either comparing coefficients or polynomial division, because they're both really important. They've come up hundreds of times in these step questions so far.